the next one, page 27. This is step 5. We're gonna use another condition to find out this is actually one of the special case in the buckling analysis. We're going to find out the values of V and P, because in the expression that we have here, now we have found the expression for Y in terms of X, but we still do not know what's the end moments, and we also don't know what the shear is, right? We don't know MA, we don't know V, and P is provided K is related to P, so you can consider both P and K are known. But we don't know MA, we don't know V. So let's find out, and that's actually how we're gonna use it to determine the critical load. To find out the moment and the P, they have to be determined simultaneously. We're gonna use this condition. And because we know that the second boundary condition, which is when X is at support B, there's no deflection. And to make this to be true, we'll plug in the value of L into the expression of Y of X, and that will give us this result, which is capital V over PK times sine KL minus MA over P times cosine KL minus V over P times L plus MA over P must be 0, right? So this is the condition which is here. Now we have not used, now we are using it, is this one. We already use this one and this one, but we haven't used the other two, so that's what we're going to use, these two. So we just use this one, and next we're going to use this. So the next one is because Y prime at L must be 0, so we plug in expression of Y prime. This is V over P times cosine KL plus MA times K over P times sine KL and minus P, V over P. And this is the slope expression, must be 0, right? So we just plug in. Now let's observe this. Of this expression. You can actually compare these two. And what do we see here? We see that, first of all, you can get rid of P, right? Because everything is associated with P. Correct? In fact, we can actually do this. And if you multiply everything with a P, and let's call this equation 1 and the other one equation 2. You probably observe there's some similarities between these two expressions, right? Now, we can do either way. There are multiple solutions. Either you divide equation 2 by K, or you multiply K in equation 1. We can do either way. To use the matrix approach, and this is 5, so we will still continue. This is still 5. We're going to write equation 1. Equations 1 and 2 into the matrix form. us. So how do we write it in the matrix form? In equation 1, we have this, right? So let's write it like that. By putting the terms associated with MA together and the terms associated with V together. So let's write it this way. The first one, and you can do the MA or V. If we do the MA first, that means I'm going to take everything, take MA out, and put everything together. From equation 1, that is 1 over P, because that's MA over P, minus 1 over P times cosine KL. And this is everything associated with MA, right? From equation 1. For equation 2, take V out, plus V times, the first term is 1 over P over K times sine KL, and minus L over P. This should be 0. That's from equation 1. And from equation 2, we do the same. Take whatever is associated with MA out and put it in the front. And there's only one term. So this will just become K over P times sine KL, and that's it. Plus V times 1 over P times cosine KL minus 1 over P. And this must be 0. So we rearrange the terms by separating everything with respect to MA and V. And now we can comfortably cancel out the P, because we don't need a P here. But remember, if you cancel out 1 over P, you still have the constant unity here. So please do not forget about that. If we express it in the matrix form, it looks like this. The first element is 1, 1. That means 1 minus cosine KL. That's for MA. And 1, 2 is this, just 1 over K times the sine. And maybe we should write it this way. I think that's easier. Just write this like sine KL over K minus 1. That's from the first equation. And
it
the
should be minus,
of course,
right?
is MA times V. So what we did was just the first 0. Right? That should be L. And the second one is K. Element 2, 1 is K times the sine KL. And element 2, 2 is the coefficients associated with V. And that's cosine KL minus 1. That will be 0. Correct? Now, mathematically, for all the combinations for the values of MA and V not to be zeros, the determinant of this matrix must be 0. And you remember, this is something that we did in the past, correct? Use the determinant condition. For the internal reactions not to be 0, the determinant must be 0. That means the determinant of this expression must be 0. And this is 2 by 2, so you know it's very straightforward to find the determinant. The determinant of this 2 by 2 matrix is, I would just write like this, equals to 1 minus cosine KL times cosine KL minus 1 minus sine KL over K minus L times K sine KL must be 0. Which is simply this term times this term to be positive. And this term times this term must be negative. And put them together. Okay. And then this can be written like the following result, which is this. And this can be written as sine KL over 2 times KL over 2 times cosine KL over 2 minus sine KL over 2. This must be 0. Of course, to get to this point, you notice I already apply the half angle equation, right? I already replaced KLs with half KLs. And you can use the expressions that I have provided with you earlier tonight. So here, this is the final characteristic equation for finding the buckling node. And it's not a simple question that we can actually analyze it, but if we ignore the first order terms, and we only focus on the higher order terms, and there's one solution that we can actually find it by hand, which means that when KL equals to 2 n pi, and here n is integers. That means n equals 1, 2, 3, so on and so forth.
Professor, really quick, what does that upside down A mean?
Upside down A means for every, and sometimes means for all. That's just a mathematical symbol.
All right, thank you.
Sure. I will use it, as you can see that I also will use other symbols from mathematics, but whenever it's not clear to you, just ask me. All right. Now, the first root in this case is when n equals 1. So that means KL is just 2 pi. When KL is 2 pi, PCR is 4 pi squared EI over L squared.